Yes, we did it. Welcome to my YouTube channel. What did we do? We are on the 25th question, the 25th exam style non-calculator question. Yes, we did it. Let's clap for ourselves. Now, this 25th question is talking about a mixture of things, but basically calculus. How did I see calculus here? Differentiation. When we talk about stationary points, we're talking about differentiation. But let's not jump the gun. Let's start with question 25AI. You're welcome to my YouTube channel once again. Have you subscribed? Have you been enjoying the videos? Do you have any questions? Please leave all your questions in the comment section. The links to the previous videos will be in the description box of this video. Please don't miss out on them. All right. So here we've been told to find the value of y when x is -1. All you need to do here is to substitute x as -1. So y becomes y equals to 1 raised to power 4 minus 4 into bracket. Sorry, that's -1. -1 raised to power 3. -1 raised to power 4 is 1. -4 minus 1 raised to power 3 is -1. So we have 1 minus 4 times -1. -4 times -1 is a positive 4. So we have 1 plus 4, and that gives us 5. All right, now to the juicy question. Find the coordinates of the two stationary points on the graph of y equals 4 x raised to power 4 minus 4 x raised to power 3. Exactly the same function, but we are not asking for the stationary point. When you are asked for the stationary point of a curve that you do not have access to, the easiest way to find the stationary point is to differentiate the function. What do I mean? Please remember that stationary points are also known as turning points. That is where the graph changes direction. Now, for you to find a stationary point, you need to differentiate and set your differential to 0. At the stationary point, that is at turning point, the y, the x, that is the first differential, is 0. Okay, so what we need to do is to differentiate this function. So differentiating the function will give us, when you want to differentiate this, the power comes down and you reduce it by 1 up there. So the power coming down is 4. X, reducing it by 1 gives us x raised to power 3. It's that easy. Yeah, that's easy. Okay, minus, the power comes down. The original coefficient there is 4. So the power joining it makes it what? 12. And we reduce the power by 1. So that is 12x raised to power 2. We're done differentiating. Remember, we said that stationary point, the differential is 0. So 4x cubed minus 12x squared equal to 0. When we've done this, the next step to take is to factorize, because you're trying to solve. When you're asked to find coordinates of the stationary point, it means that you're looking for a pair of coordinates, the x and the y. So we're going to look for the x now and then substitute it into the original function to find the y. Please stay with me. Now I'm going to factorize this. The highest common factor of these two terms here is 4x squared. In the bracket, I'll have x minus 3 equal to 0. Beautiful. Now, since I have this, I know 4x squared equal to 0 will imply that what? X is equal to 0, or x minus 3 equal to 0 will imply x equals to 3. So my two values of x are what? 0 and 3. Now I need to find the corresponding values of y. When x is 0, when x is equal to 0, I put in x at 0 there. Y will become what? 0. So here I have 0. When x is 3. I need to substitute 3 in there. So it's going to be y equal to 3 raised to power 4 minus 4 times 3 raised to power 3. 3 raised to power 4 is 81 minus 4 times 3 raised to power 3 is 27. So that's 81 minus 108. And that gives us minus 27. So when x is 3, y is minus 27. Okay, so that is that on that particular question. And the final question on this paper. Y is given as x raised to power p plus 2x raised to power q. The y, the x, is given by 11x raised to power 10 plus 10x raised to power 4. So we've been told that this function has been differentiated. What we need to do is to actually differentiate the function y and then see what we have. So if y is equal to x raised to power p plus 2x raised to power q, when I differentiate this, the y, the x, it will be, remember the power comes down, that is p, x raised to power p minus 1, plus the power comes down here again, so this becomes 2q x raised to power q minus 1. So this is what we are going to compare to what we are given. Here we are given that it's supposed to be equal to 11 x raised to power 10 plus 10 x raised to power 4. By comparing the two, we see instantly that our p is 11 and 2q is 10. So q will be 10 over 2, which is 5. So our q is 5. Yes, we have come to the end of this video. Thank you so much for watching. I hope you learned a thing or two on how to answer exam style non-calculator papers. Please remember your knowledge of your square numbers and your cube numbers will be very, very handy to help you navigate your exam, your non-calculator papers. Thank you so much for watching. Thank you so much for watching and see you in the next video. Bye.